Substitution level 2. And again, this comes from Google Classroom. These are the expectations. Write down both equations. Use arrows to show sequence. Do not skip steps. Box final answer. So let's write down both equations. I have x minus 6y equals 22. Underneath that, I have x is equal to negative 5y. When we're dealing with substitution, we want to look for a variable that's isolated. Isolated by definition means by itself, alone. So in the second equation, I see that x is isolated by itself right there. So when that variable is isolated, that means that this variable x is actually equal to whatever's on the right side. So what I'm going to do is I will circle negative 5y because it is equal to the x. And then what I'm going to do is I'm going to take that negative 5y and I will substitute it over here for x. So literally, I will get rid of that x, and in its place, I will put negative 5y. So I'm just going to go ahead and transfer the whole top equation over here. Again, I will get rid of the x, and in its place, I will put negative 5y. So notice negative 5y takes the place of x, and now I'll rewrite the rest of the equation, which is negative 6y is equal to 22. Negative 5y minus 6y, those are both variable terms, so we'll just combine those automatically. That's going to simplify to negative 6y equals 22. And then to get rid of this coefficient, or negative 11 times y, we'll divide by a negative 11 on each side. Negative 11 divided by negative 11 simplifies to positive 1. And then positive 1 multiplied by y simplifies to just y. 22 divided by negative 11 is negative 2. And now I know that y is equal to negative 2. So I could come over here and I could plug in negative 2 right there. There's nothing wrong with that. Now I do want to go ahead and point out that we don't know what our x value is. In order to find our x values, we're going to have to take this negative 2 and we can substitute that back in for y in the first equation or in the second equation. But I'm going to suggest that you go with the equation you start with, because notice we already know what y is and what we're after is x. So by substituting it into the equation that you started with, it's going to speed things up a lot more for you. Again, the top equation works, but it's more work. So I'm just going to go ahead and take this equation over here, and I'm going to put x equals negative 5, again sticking with the strategy where I substitute. I'm going to put things in parentheses, so instead of y I'm going to put parentheses and then negative 2. So literally my x is going to be equal to a negative 5 multiplied by a negative 2. Well, negative times a negative is a positive, right? And then 5 times 2 is 10. So we actually just found out what our x value is. So our final answer is going to be expressed as an ordered pair. My x value is 10, comma, negative 2. And let's go ahead and box our final answer, and then let's get some feedback and see how we did. So 10 comma negative 2, and we are good to go. I actually want to see his steps. So yeah, he put in negative 5y just like we did over here. So this step, actually, let me go and just underline this. This step is the same as his right here. And then it simplifies. That makes sense. And then this step where he put x equals negative 5y, that's kind of this step right here, or when we substitute negative 2 in right there. And then he got x equals 10. So kind of the same thing. See how the similarities between delta math is the same as mine. Let's try one more equation, but move a little bit quicker. All right, so the next one I chose this one because it's kind of simple. It's actually a little bit harder. So we've got y equals x. We have a y isolated on the left side, and we have an x isolated on this side. So really, the one we substitute can really go either way. I just want to remind you, though, in our first example, we chose this negative 5y because x is isolated. So because x was isolated in the first one, let's pretend that we're after the fact that y is isolated on the left side. So what I'm going to do is I'm going to go ahead and take this x right here. And because y is equal to x, I can literally substitute wherever there's a y in the second equation, and I will put in its place x. Or you could, similarly, you could go ahead and put a y in for this one. You'll still get the same solution. All right, let's just move this equation over here to the side. So I have negative 2x minus 5. I'm going to get rid of that y, and in its place I can put an x because we stated earlier y is equal to x, so we can trade them out. So negative 2x minus 5 times x is equal to 35. So let's simplify negative 5 times x. So that's going to be negative 2x minus 5x equals 35. Negative 2x and negative 5x, those will combine to give us negative 7x equals 35. Divide by negative 7 on each side. Again, negative 7 divided by negative 7 is positive 1. 1 times x simplifies to just x. 35 divided by negative 7 is negative 5. So now that I have a negative 5 value, since I have x equals negative 5, all I have to do is to substitute negative 5 either back into the first equation right here where x is, or into the second equation. But like we did in the last one, the equation we start with is probably the quickest way. So just like I substituted negative 2 back in for y because x was isolated, I'll do the same thing. I'm going to take negative 5 because it's equal to x, and I will substitute it in for x in the first equation that I kind of focused on, which is y equals x. So y is equal to parentheses negative 5, which would simplify to just y is equal to negative 5. All right, let's write our final answer. My x value is negative 5. My y value is negative 5, which kind of makes sense, right? If x and y are equal to each other, they should be the same. And let's box that, and let's see how we're doing. Now, just by way of review, before I even hit this, I do want to remind you that if you wanted to verify you had it right, say like on a test, all you would have to do is substitute x in for y in this equation and the second equation. If it works both, it proves it. All right, let's see how we did. We got it right. We're good to go. And so notice they did the same. Oh no, they actually went and put y in for x, but doesn't matter. So they had y equals negative 5, which we knew, and then they substituted. So same answer, he took a different approach. Thanks for viewing. Hopefully you found it helpful.